In this lesson, we talk about the technique of partial fractions. This technique is used to find the integral of rational functions. Before explaining this technique, I need to make a reminder, a simple reminder, that will be helpful in this discussion. As you know, the integral of 1 over x, it is ln of absolute value of x plus c. And if instead of x in the denominator, we have any other linear factor in the denominator, like 1 over x plus a constant k. That constant k could be positive, negative, or 0. By using a simple substitution, letting u be x plus k, we can conclude that this is going to be ln of absolute value of x plus k, and then plus c. So if we have a linear factor like x plus k in the denominator, the integral of 1 over x plus k is going to be ln of absolute value of x plus k. So these two, or in fact the second one, which is more general, will be very helpful in the discussion that we have today. Now let's see what is the technique of partial fractions. Let me explain that on one example. Suppose I want to find the integral of a rational function. It's a fraction. On the top, I have 3x plus 11. At the bottom, I have x plus 1 times x plus 3. Or from the beginning, the denominator could have been given as in the standard form, x squared plus 4x plus 3. But for simplicity, let me just give the denominator in the factorized form. As you know, x squared plus 4x plus 3 can be factored as x plus 1 times x plus 3. So for making it more simple, let me give it in the factorized form. So to do this kind of integrals in this example or similar examples, we have two steps. Step one is the algebra step. Forget about the integral. We try to write this fraction 3x plus 11 over x plus 1 times x plus 3 as the sum of two fractions. One of them with the denominator of x plus 1, this factor, and the other fraction with the denominator of x plus 3, this factor. What we are going to do in this step is we need to find out what constants, what numbers will be in the numerators. So I need to figure out these two sides are equal for what values on these two numerators. Let me give names to them and we try to find them. So I want to find what are the values of a and b such that the two sides, no matter what x is, they are equal. So let's find the common denominator on the right side. The left side is as it is, 3x plus 11 over x plus 1 times x plus 3. On the right side, the common denominator is the product of those denominators. This is something that you know from basic algebra. So the first numerator becomes a times x plus 3, and the second numerator becomes b times x plus 1. So I'm just doing some basic algebra calculation. So these two sides are equal. I see that the denominators are the same. So I can cross the denominators. This denominator and this denominator, they cancel out. Let me continue on the next page. So what we have is 3x plus 11, the left side, the numerator on the left side equals the numerator on the right side. I crossed the equal denominators. So a times x plus 3 plus b times x plus 1. The left side is in the standard form. Let me write the right side in the standard form as well. So if I distribute a over these parentheses, that's going to be ax plus 3a. And if I distribute b over the other parentheses, it's going to be bx plus b. So ax and bx both have x in common, so I can factor x out. It's going to be a plus b times x. And 3a and b are just the constant part of this linear factor. So 3x plus 11 is identical to a plus b times x plus 3a plus b. These two sides are identical no matter what x is, so I can set the corresponding coefficients equal to each other, meaning that 3 is the same as a plus b, and 11 is the same as 3a plus b. So let me form the system. So 3 is a plus b, or a plus b is 3. And 11 is 3a plus b. So 3a plus b is 11. So we need to solve this system of two equations into two unknowns to find the values of a and b. You can use any method at your own choice to solve this. For instance, I can multiply the first equation by -1 and then add them up, so b cancels out. Let me do that. So to get rid of b here, I can multiply the first equation by -1. So I have minus a minus b equals -3. The second equation is 3a plus b equals 11. Then add up these two equations. Left side added to the left side, right side added to the right side. Minus a plus 3a is 2a. Minus b and b cancel out. On the other side, minus 3 plus 11 is 8. So 2a is 8, a is 4. If a is 4, knowing that, like from the first equation, a plus b is 3, this equation here, I can conclude that by knowing that a is 4, b is going to be -1. So b is -1. So the bottom line of step 1 in this problem is 3x plus 11 divided by x plus 1 times x plus 3 equals a over x plus 1. By this calculation, a was 4, plus b over x plus 3. And by this calculation, that b was -1. Step 2 is the step that we complete the solution of the integral. So in step 2, we go back to the question. The question was the integral of 3x plus 11 over x plus 1 times x plus 3. By step 1, I know that the fraction 3x plus 11 over x plus 1 times x plus 3 can be written as the sum of these two fractions, 4 over x plus 1 and plus minus 1 over x plus 3. This integral is quite simple. First of all, it is the sum of two integrals, the integral of 4 over x plus 1 plus the integral of minus 1 over x plus 3. From the first integral, 4 is a constant, can be pulled out. From the second integral, negative 1 is a constant, can be pulled out. So what I have here is 4 times the integral of 1 over x plus 1, and then minus 1, or minus the integral of 1 over x plus 3. Now it makes more sense. That's why I made this reminder that the integral of 1 over x plus k is ln of absolute value of x plus k. Let me go back to this problem. So the integral here is ln of absolute value of x plus 1. And this integral is ln of absolute value of x plus 3. So that's the absolute value sign. Let me write it properly. And then the final answer that I want to type in this box is going to be 4 times ln of absolute value of x plus 1 minus ln of x plus 3. And then since it's an indefinite integral, a plus c at the end is needed. Okay, as I mentioned, sometimes the denominator is given in the factorized form, as we had in this example, that the denominator was given in the factorized form. And sometimes the denominator is not given in the factorized form, and we need to factorize the denominator. But the nature of the solution, please try this on your own before watching my solution. And that is the integral of 16 over x squared minus 4 dx. I want to solve this using the technique of partial fractions. So as we did with the in the previous example, step 1 is the algebra step. And I write this fraction as the sum of two fractions. First of all, remember that x squared minus 4 is factored as what? Is factored as x minus 2 times x plus 2. From basic algebra, we know that a squared minus b squared is a minus b times a plus b. So if I want to write this as the sum of two fractions, the denominator of one of them is x minus 2 and the other one is x plus 2. It remains to determine what are a and b. Please try to find a and b the way that I did for the previous example. So the left side remains as it is, 16 over x minus 2 times x plus 2. On the right side, I find the common denominator, which is the product of x minus 2 and x plus 2. So the new numerator for the first fraction is a times x plus 2. For the second fraction, b times x minus 2. Now the two denominators are the same and the two sides are identical. So no matter what x is, on the left side, 16 equals, on the right side, 8. So on the right side, I have 8 times x plus 2 plus b times x minus 2. So what is a times x plus 2? It is ax plus 2a. And what is b times x minus 2? It is bx minus 2b. So 16 equals, if I want to write the right side in the standard form, ax plus bx is going to be a plus b times x. And then the constant part, 2a minus 2b. So plus 2a minus 2b. Do you remember in the previous example how we dealt with this step? I set the coefficients, the corresponding coefficients on both sides equal to each other. Let me go back to the previous example. Like 3x plus 11 was a plus b times x plus 3a plus b. I set a plus b equals to 3 and 3a plus b equals to 11. But here I see that on the left side, I just have 16. I don't have anything times x. So I can write here a 0x here because I don't see anything on the left of 16. Why I do so? Because I need to compare the corresponding coefficients. Nothing before 16 means the coefficient of x is 0. In other words, 0 is the same as a plus b. And 16 is equal to 2a minus 2b. Let's solve this system of equation. You can choose any method at your convenience, whatever works for you, like elimination method, substitution method, whatever you would like to use from basic algebra and solve this system of equation. Like for instance, the first equation, a plus b equals 0. The second equation, I see that all the coefficients are even numbers that have 2 in common. If I divide both sides by 2, I will have a minus b equals 8. And now if I add up these two, b and minus b cancel out, then 2a equals 8, so a is 4. And knowing that a plus b is 0, if a is 4, b is what? Minus 4. So this tells me that step 1 gives us that 16 over x minus 2 times x plus 2 is a over x minus 2 plus b over x plus 2. By the calculation that we just did, a turned out to be 4 and b negative 4. Now, step 2 is to find the final answer. So the integral of 16 over x squared minus 4, as you know, x squared minus 4 is x minus 2 times x plus 2, is the integral of the sum of those two simple fractions, 4 over x minus 2 plus negative 4 over x plus 2. So this breaks down into two integrals, 4 over x minus 2 dx plus negative 4 over x plus 2 dx. In the first integral, 4 is a constant, can be pulled out. In the second integral, minus 4 is a constant, can be pulled out. So I'll have 4 times the integral of 1 over x minus 2 and minus 4. So here I will have minus 4. The integral of 1 over x plus 2. By the reminder that we had at the beginning of this video, this integral of 1 over x minus 2 is ln of absolute value of x minus 2. And the integral of 1 over x plus 2 is ln of absolute value of x plus 2. So the final answer to this example that I'm gonna type in this box is 4 times ln of absolute value of x minus 2 minus 4 times ln of absolute value of x plus 2. And since it's an indefinite integral, plus c at the end.